research that has produced results that have caused an international discussion on whether information should be published and whether research in the area should continue. And this is about the virus H5N1, avian flu, bird flu, and it's about modification of the virus. And it's about the modification that is, we consider, controversial. So, as with all the other exercises, we have some objectives. To understand some of the experiments, but we're not expecting you to describe the detail, why it's considered as dual use, and then to look at the role of scientists in contemporary society. The work that was done on H5N1 was such that there was a possibility that after modification the virus could be transmitted between humans. And this is why there has been an enormous discussion about it, and why that discussion is actually continuing. So it is we're in the middle of a process of discussion about this particular virus. And H5N1 is family of viruses, highly pathogenic in birds and particularly contagious, which means it can be passed from one bird to another. And it is fatal, particularly in domestic fowl, domestic birds. There have been a few sporadic human infections. There have been some deaths with H5N1. And this is why there is interest in it, but also why some of the research which I'm going to talk about is controversial. The two authors who did the controversial work, Ron Foucher, who's from the Erasmus Medical Center in the Netherlands, Rotterdam, and Kawaoko from the University of Wisconsin in the USA, were doing research that was commissioned by the US National Institutes of Health. And it was very specific. It was to answer the question whether this avian flu could become transmissible and sustainable in ferrets. Now ferrets, do you know what ferrets are? Ferrets are sort of like the form of squirrel. But they are animals that have been used for studying viruses since the 1930s, and they are a good model for studying human infections. And this is why the question was raised, was it possible to get to a point where the virus could be transmissible within ferrets? If it was transmissible in ferrets, then there was a distinct possibility that that virus could also be transmissible to humans. And there was a risk then of being highly contagious for humans. So, in essence, what the two authors did was repeat passage and replication of the virus in ferrets to look at it as a model for human influenza transmission. Ferrets not only are good models, but they have a form of influenza that is multi-organ, involves the neurological system, and you see virus replication in the brain. So if ferrets become infected, it is very easy to detect that infection. And the outcome of these experiments that were done separately, using different processes, they showed that new strains of H5N1 could achieve aerosol transmission in ferrets, which meant that when the ferret coughed or sneezed, they would produce little droplets, which would take the virus to another animal, say a naive animal or an uninfected animal, and that animal in turn would become infected with the virus. And just briefly, provide you with the details, or you can look at the experiments in detail if you want to. But just as an example, Kawayoko did random mutation with the virus and looked at an area of the virus. You see H5N1, the H stands for hemagglutinin, and the N for neuraminidase. And there are variations on hemagglutinin and neuraminidase in the different viruses. The viruses can be called H5N1, you can have H16N9, you can have a variety of different combinations of hemagglutinin and neuraminidase. And what Kawayoko did was modify the protein that allowed the virus to attach to receptors on the upper airways in humans. And there were two changes introduced randomly in the virus that allowed it to attach to the receptor. So this is the mutated protein on the virus. Those two mutations allowed it to attach to the receptor, and the mutated gene, or the mutated HA gene, was then combined with a number of genes from a different virus. And this is the 2009 H5N1 pandemic virus. H5N1, very similar to the virus that caused flu after the First World War, and where there was the number of deaths in the region of 30 to 50 million worldwide. So H5N1 is highly transmissible between humans. And because of the nature of viruses, these are RNA viruses. It's not DNA, it's RNA. And because of the assembly of the RNA, it's very easy for viruses to change RNA. And as a result of the reassortment here, they ended up with a virus that had a third mutation. And this hybrid, the mutated protein and the gene for the mutated protein with H5N1 genes, enabled the virus to then infect ferrets. So there were 3 mutations in the genes, which then changed H5N1 into something that would infect ferrets. And so they put it in the nasal passage of the ferrets, and the ferrets became infected. They then were able to investigate a 4th mutation, because when the ferrets were in the process, they had become infected and they sneezed and they produced aerosols, they contaminated other animals, and they found that further mutation, that there was a further mutation, and what this 4th mutation meant was that the virus had become stabilized. So infected ferrets could infect others, and 4 simple mutations in the genes from H5N1 and the combination with H5N1 allowed a virus to be produced that was transmissible in ferrets and therefore potentially transmissible in humans. So this was the work that was done in Wisconsin. The approach taken in the Netherlands was a slightly different approach. They took some material from a person who was infected in Indonesia and investigated the virus. What they did was very specific mutations in H5N1, site-directed mutagenesis is called, and produced mutated virus, which was also transmissible in ferrets. So there were 2 independent approaches that arrived at a mutated H5N1 virus that was transmissible in ferrets, and therefore the potential was there for it to be transmissible in humans. So the question was, and is, should this information be published? What you've done and what you have is a virus for which there's no immunity. You know, these are new viruses, novel viruses that are infectious in ferrets. The work was done in laboratories. If you publish the information, you put it out for the general public, other scientists to know, and what mischief might they make with this information? Because there isn't an antidote, there isn't a vaccine to this particular virus. So should it be openly published? And this is what the authors wanted. They wanted this information to become public, like any scientist. They wanted the information out there. You came up with a whole list of ideas as to why information should be published. So what I want to do, first of all, is I want you to tell me how the virus works. I've got an activity up here and I've got 5 groups. What I'm going to do is I'm going to merge 2 of those activities. And what I would like table 1 to do is to look at virus attachment and cell entry. I'd like you to use whatever electronic media you have, laptops, smartphones, and for group 1 to do virus attachment and cell entry. For this group here to do nuclear entry and transcription of the virus. For group 4, or this third table here, to do transcription and replication. So a bit of overlap. And the final group at the back to do assembly and budding of the virus. So we have about 15 minutes to do this. You have pens and paper. Use your devices. You can, as I say, use your devices. You are at liberty to use the material to draw something. It's not going to be Okay?